So we're going to be talking about supply chain. How many of you have thought about it? There's 3 of you here. Yes, yes, yes. I know. Right, so I assume maybe people will be like, oh, okay, but we're going to start anyways. So yes, SBOMs are something that we have had recent discussions on. I think that it's important to start this session by saying we've had SBOMs for a long time now. We've been able to generate SBOMs since I've been doing this. We used to call them build audit reports. For at least 20 years. So SBOMs are not new. They're just finally being recognized for what they do and the insights that they provide. But we'll walk through and we'll just talk about some of the challenges, why what Ortelius is about and how we've created. Do we have a clicker that I can use so I don't have to come back up here in my little corner? Oh, I probably don't. Oh, there we go. Yep. Oh, there we go. Okay. Is that going to work now? I don't think it is. Did something, huh? Doing something. How did you do that? Oh, this one? No, this one. Okay, great. All right. Okay. So recently, I think the reason why SBOMs have gotten some more visibility is because we have had some big vulnerabilities like Log4j woke everybody up. Many of us who are in the industry said, oh, you know what, that was going to happen. It just finally did. And the Linux Foundation started taking note, and the US government started taking note as well. If you want to learn more about SBOMs and what the Linux Foundation is doing, I probably should have not just put that. I should have probably put the full link. But you can download this session and you can get the link. But they did a document called SBOMs and Cybersecurity Readiness. Highly recommend you read it. It's a really good read. And as Jim Zimlin points out, is that SBOMs really will play this essential role in the security process. But we have a way to go in order to make them truly secure in what they need to do. The Biden administration signed an executive order. It says, hey, if you're doing business with the US government, you need to be able to provide us a bill of material. We want to know what we're consuming in our platforms now. I believe it goes into effect in September or sometime towards the end of this year. So SBOMs obviously have the attention of the US government. I am Tracy Ragan. I am the community manager for the Ortelius open source project, which is incubating at the CD Foundation. I also am the CEO and co-founder of a little company called DeployHub. I call us the little company that could. I have been recognized as a tech beacon, which is kind of cool. It's kind of fun to have that happen. And I'm also on the board of the OpenSSF. I'm involved in what they call Stream 9 of the government SBOM evaluation, I would call it, that the Linux Foundation is working with. I actually helped found the Eclipse Foundation, which is really fun. And I was a founding board member of the CD Foundation as well. So I have been around open source for quite some time. I love it, and I know that we need to fix it. So let's just talk about this session is specific around microservices and the challenges with SBOMs with microservices. There are plenty of challenges with SBOMs in the monolithic world. I'll give you one big one. There's a massive gap in SBOMs from the time that you generate it and it's sitting underneath your CI/CD pipeline in the format of a file. Somebody could take that and delete the packages they don't want anybody to see and move forward, and nobody would know the difference. So they're not immutable, which is a problem. But that's a problem for all SBOMs, not just microservices or monolith. That's just a problem. And I can talk to you about what we're thinking about doing to solve that. But in a monolith world, when we create the SBOM, we do it at the time we do the software compile and link step. So we take all of that information, and that's where the SBOM gets generated. So you have an SBOM for each application version. And that's what, for example, the US government wants to see. They don't care about seeing an SBOM for every single microservice that your company produces. They want to know what an application version SBOM looks like. Now, why that's important is because actually, if you take two SBOMs from an application version and you compare them, you can see the difference, what was different between the two releases, and you can drive down and see all your vulnerabilities. So application level SBOMs will continually be what are used to determine if an application, the higher level software solution, is secure. But in microservices, we decompose all that. So we have hundreds of potential of SBOMs, and how do you collect that all together and produce that as a single report at an application version when we're not even thinking about application versions anymore? And I feel like that's one of the reasons why microservices are often seen as being super complex. They are because the North Star that we always had is now gone. It's like we're trying to calculate our longitude and we have no North Star to follow. So the loss of the application really causes a lot of struggling. It causes, I guess we call it toil, right? Application teams are required to produce an SBOM, and I have talked to some organizations that are trying to do a microservice implementation, that are trying to produce SBOMs, and what they use is an Excel spreadsheet to try to track the pieces and parts of their application, and that doesn't work in an environment where you're really pushing things across the pipeline as quickly as possible. You can't easily find the providence if you don't have an SBOM, so that becomes another issue for the application teams. And at the end of the day, we're really trying to find vulnerabilities. And the way you find a vulnerability is to know what's in your package, and the way you find your package is through an SBOM. So it all kinds of trickles up or trickles down from the SBOM. And that's what oftentimes causes this problem. And where the problem really resides is around transitive artifacts. How do you know what those are? And we can get this information. We have fabulous tools like, the JFrog folks who are here. Go talk to them about the tools that they use. We love JFrog. And they have that information. But how do you calculate that and bring it up to the application level? So this is another tip. This man, Tyler Jewell, I have so much respect for him. He is brilliant. He is kind. He has supported us from the very beginning and given us lots of direction. But he wrote this article in the beginning of the year, and he always does. He calls it the developer-led landscape. Every year he produces it. He works on it all through the year, and in January he produces it. He talked about this idea of a service governance catalog. And that's the only way to really start tracking complex software systems. And he talks about how we're creating such big, complex systems that we can't rely on the buildmeister to figure it out. Now, I was a buildmeister for a long time, and I know what that feels like. You kept everything in your brain about how something got compiled. And so if something went wrong, you would get called, and you would get asked, and you'd be able to produce the answer fairly quickly because you spent, 6 hours trying to get it to compile. But in a microservices world, the complexity grows beyond the human brain and what one person can possibly understand. And quite honestly, nobody wants that job anymore. It is a job that should have been tossed out the window a long time ago. We still have buildmeisters who are really struggling to pull stuff together, but in a microservices world, that does change. So we're going to talk about Ortelius. It is one of the first incubating projects at the CD Foundation. I'm very proud of that fact. We started in COVID is lost. I have no reference of time. It's only pre-COVID and post-COVID. It was sometime during that time. I think it was, this is 2022, so it would have been 2021 or December of 2020 is when we got accepted into the CD Foundation. And we began this journey of building this really amazing, diverse community of open source contributors. And what Ortelius is it's a central catalog that it's basically a big old relational database that starts tracking where a microservice is, who's consuming it, its ownership, details like a component. A microservice is a component. We track the version, so we actually do the versioning on the back end. We do the application to component relationships. We track the component blast radius. Over here on the right-hand side, we see our cart service, and that's the component, and it's impacting multiple versions of this particular product we call the hipster store, probably because in this image, it was running in multiple clusters. We track the service and application SBOM. So every service has an SBOM. It gets aggregated up at the application level, as well as the CVEs, the ownership, and where it's deployed across the inventory. So the company that I run is called DeployHub. What we're gathering is a hub of deployment information that includes things like the CVEs, the inventory, the versioning, all of the things, all of the pieces of this giant Lego system we're building. It's almost like what we do is, you know how, if you're a mom and you have kids with Legos, you've organized the shapes into different bins. That's what we're doing. We're organizing the shapes into different bins, and we're tracking how many shapes there are. So I said we have a fabulous group of open source contributors. One of the things we did before the beginning of this year, we had our first election of a governing board. These are all requirements to eventually become a graduated project. We have a long way to go at the adoption level, but we're putting together the infrastructure in terms of the project itself. We have Brian Dawson, who now is with Ripple. I think some of you know him from the CloudBeast days. We absolutely love Brian. Steve Taylor is, I like to call him our big giant head. He is the architect. He's a brilliant, brilliant technologist. Literally, this man, you can ask him any question from the mainframe through Kubernetes, and he will know it. I don't know how he does, but he's got some weird thing in his head that he can remember those tiny details. We really push to bring in women to this board. And Aisha, she's out of Pakistan, which is really fun to have this kind of global community. And she started as a project manager, and what she wanted to do with her career is to become more technical. So we threw her all the hardest things. So she worked with Steve, and they built out quite a bit of the architecture. Sasha is out of South Africa. He is one of the funniest people I ever have met in the technology area. But then when he goes to do a presentation, he's all very professional, and we're all like, come on, Sasha, we want to see the real you. And then Anne-Marie Fred and Sergio Canales, they're both from Red Hat. And Red Hat's been watching pretty closely what we're doing, and our adopters. Siddharth Parikh, he's from NatWest Group. It's one of the largest banks in Europe, and they've been adopting and sort of learning from the community as we've grown. And we have an amazing group of contributors. Brad McCoy, Karam Singh, Utkar Sharma, Phil Gibbs, Ben Poe, Saim Safdar, Arvind, and Adam Gardner. This kid here, I have to brag because he is only a junior in college, and he has 17,000 followers. He works his hind end off. He really does. And anytime we ask for something, he always raises his hand. It's like, you want to run for the governing board? Sure. He didn't get elected, but he still threw his hat in the ring. So what are we up to? What is this group of fabulous people up to? We really are up to what I like to call taming microservices. And we have to tame microservices by collecting the data about them. So DevOps teams use Ortelius to track the service inventory. So knowing things like what the drift might look like. So how many of you out there have started doing cloud native and you only have one cluster? None of you, of course. There's hundreds of clusters. Clusters have turned into, as a developer, I used to ask for having my own server under my desk because I wanted a nice protected environment so our team could put things on it, test it before we push it out, which was a really bad idea, to be quite honest. But that's what clusters are doing. Now we have, infrastructure as code. Anybody can spin up a cluster, so you have hundreds of clusters. Well, if you're using services in a way that is shared, you could have services that are running on clusters that are different versions. That's the reason why we have to understand all in one place what versions of the services are being used and where they're being used. Microservice developers, companies that are doing microservices, I tell them that sometimes I feel like they have one big junk drawer. I have a junk drawer in my kitchen. If there's something that's lost or something I don't know where to put it, I throw it in the junk drawer, and later I go, oh yeah, I remember, I put it in the junk drawer. There's scissors in there, there's, I don't know, chopsticks, matches, all kinds of weird things. In fact, when I was a kid, and I loved Christmas as a kid, of course, I would go through the junk drawer because I didn't have money, and I'd wrap things for people. So I've kind of kept that kind of mindset, is that everything goes in the junk drawer. And what we're doing with microservices is we're throwing them in the junk drawer because we have no way to organize them, even though we may have spent a ton of time building out a domain-driven structure for them. Every microservice has a particular focus area. It solves a certain problem. And being able to communicate that so that we can find and share them is important, because you can't just throw them all in the junk drawer. So Ortelius has a domain structure that allows you to tag things, basically. It's really more than tagging. It is really a domain structure that says these microservices belong to a certain domain, and they could have subdomains. And then application teams have a way to package, I say that in quotes, package their application and a base version of their application so that they can begin tracking the changes over time. So now let's talk about, we're starting to get what's below the surface. Once we have that information, we can start tracking what's below the surface. So in that method, security teams now have a way to see SBOMs from a central place, and they begin seeing SBOMs aggregated up to the application package. Remember, I told you it's a big relational database? If you have a base version of your package and you've told me what you're using, I have that information. So you have a many-to-many relationship between microservices and applications. Applications use many microservices, and microservices are consumed by many applications. We track that many-to-many relationship. And then, of course, support teams. Can you imagine being a support person and getting a phone call from, we use the hipster store as our example. So our hipster store, I can't finalize my transaction. My credit card isn't working. Okay. You think that customer would have said, your microservice that's handling those credit card transactions are a problem. So what does the support team do? They want to call the application team to say, your hipster store is not working. And the hipster store team is going to say, we didn't change anything. I don't know. We didn't change anything. I have no idea what could be wrong. And then if you do find it out, because you're using an observability tool, and you're like, well, look at that particular transaction is having some latency. Now we know it's this particular microservice, but who do we call? How do we know who's using it? Something as simple as that is a challenge with microservices. So let's talk about how Ortelius works. It is a big, fat database. At the beginning, if you're an API developer or microservice developer, you're a producer. And you register your microservice specific to a domain. And at that point in time, you tell us what CD pipeline it's using, what the tools are that you're using. If you're an application team, you're a consumer, you're also a feature team, but your feature is specific to your hipster store jar file, for example. You're going to create a package, and it's going to be a base version as well. So now we have a base version of the service, and we have a base version of the application. The next thing that happens is the service changes. It gets registered, let's say, to Quay or Docker Hub or whatever repository you're using. Ortelius gets woke up, and we say, oh, we're triggered at the point in time a new container image has been registered. We're going to go grab the SHA. We're going to go look at the CD pipeline, and we're going to pull in the Swagger information. We're going to pull in the CVEs. We're going to pull in the SBOMs. We're going to pull in anything that we need and what we can get from that CD pipeline. At that point in time, Ortelius is going to say, okay, now I have a new version of this particular component. I know I have 10 applications that use it. I'm going to go create 10 new versions of those applications. Each one's going to have a new application version. Now, in essence, what are we doing? Think about what this is. We're creating a new release candidate. What is the very first thing that we do in our CI/CD pipeline in Monolith? The build. The very first thing we do is create a build. We take all the libraries, all the code, we link it in, and we create a new release candidate. So in essence, what we're doing is we're replacing the old build with a new build, but the new build is logical. And we're managing that so that we have this information. Now, it doesn't mean that got released. It just means that there's a release candidate out there, and the application team can make the decision if they want to push it out. With that data, we can start grabbing some information. We can show the blast radius, which we talked about. We can start generating these application-level SBOMs, and we can track the application component dependencies at the high level that we know about. And that application component dependency is what creates the new version of the release candidate. All right, so I talked about domains. We'll just walk through on some high-level screens and how it gets put together. A component is registered to a domain. In this case, it's kind of blurry, you can't see it, but our hipster store has a purchase processing domain, and it has a store services domain. Over here, it has an application domain, the hipster store. Its subdomains are its environments, and that's how we track where it's being deployed to. These catalog domains have subdomains that are specific to the problem space that each of the microservices that are being registered solve. So for example, currency, checkout, cart, payment, and shopping. And I know it's hard to see, but I know that's what it says because I've done this demo many times. When they register their component, they're going to create a base version. Up here in the red, it's circled, it shows you, it says component base version. And we're going to grab some information. So I created this demo. I put my name got pulled out, my email, my phone number. All this is actually very accurate, so you can call me if you wanted. My PagerDuty. We also can see from here that the component type is a container. And we also can see that I used Helm to do the deployment. Now, included in this, if we were doing a live demo, we could scroll down and I could show you that we are also tracking things like key value pairs. For each environment, those key value pairs might change. This is the information me as a developer is telling everybody else. When you go to use my microservices, this is how you should treat it. This is how it's being deployed, and this is what you want to use. Now, you can have different kinds of components, not just microservices. You can have a file. Think about Lambda, think about Salesforce, or you could have a database. And each one of these, between these three types, believe it or not, we can cover every kind of component. A file system component, a container, or a database component. We haven't figured out if there's a fourth one yet, but for pretty much, if it falls into a file, an application file, or a container and a database. Now, when you do register your component, we are going to start pulling in from the CI/CD pipeline information like your Swagger details, the README file, and your CVE issues and your license consumption. From the license consumption and the CVE issues, these are just based on the actual component. We are not generating that. I want to make it clear. We are a consumer of information. We consume SBOMs. We are not generating them. Okay. Now we're going to put the application team's hat on. I'll stand on this side. I'm the application team. I am the consumer. I am going to create a package in the same way I have for a long time. If I'm familiar with products like, hey, David, hello. If we've done things like Harness, you know what a package is. We've done this before. Application teams understand this. And we even built it so it feels more like a true packaging kind of piece of software. And you can see from here that this application consumed the 149 version of the cart service. And that was their base version. Now what's going to happen is a microservice developer is going to create a new version of our cart service. They're going to create a new build image of it. They're going to store it somewhere in version control or their artifact repos. They're going to generate SBOMs and CVEs. And then we're going to bring it up. We're going to suck all that information up into the Ortelius catalog. And we're going to start tracking it. And we're going to create that logical application. When we do aggregate that information, we generate application-level SBOMs and versions and difference reports. So here's kind of a picture of what that looks like. If you look up here at the component level, we had a change, and we have a 150 version of our cart service, and it generated these 3 versions of our hipster store. And here's where we're tracking where the hipster store is. It's in the hipster store cluster, and it's in the AWS cluster. So now we're starting to just track this information over time. If it didn't get deployed, you would have, it would say over here, never deployed. So you can have an application release that was never deployed because that application team didn't say, okay, I'm going to use that new service and I'm going to pull it into my cluster. Now, we have all that information. Now it's really easy. We just go out and we grab the SBOM information from all of the consuming microservices, and we create an application-level SBOM. So in this case, we have this is a fully aggregated SBOM, so it shows every single component SBOM brought up at the application level, and then we also pull it into the vulnerabilities. So now we're showing, for the application, we're showing the SBOM and the vulnerabilities in the same way you would as if you had have compiled it in the monolithic days and generated all that from the very beginning. And maybe it feels like a long way around, but we got the data. That's the important part. And we're automating it through the CD pipeline. And as a result, we get these kinds of reports. So we have the application version to component mapping. This is sort of how we started this business. Somebody asked us if we could track what components an application was using and what their versions were. We can generate this difference report. So at the application level, if you get a phone call that says, hey, I can't, somebody's having problems with your credit card, you can now go look at your application, what's running in that particular cluster, look at the version and see what may have been the problem. So right here, the cart service was the usual suspect, I'll call it. Now, from early adopters, we're being told that the reducing the sprawl and the drift of microservices is saving about 50% of time. Tracking the supply chain automatically saves 1 to 2 hours per release. That doesn't seem like a lot, but when you're doing microservices and you're trying to release all the time, it actually saves quite a bit of time. SREs are really starting to understand the need for visibility, not just observability, but visibility before you do a release. What's going to happen before I do a release? And then we really want to evolve the CI/CD pipeline so this information is being tracked with it. For more information, please come and visit the Ortelius team. If you've never contributed to an open source project and you're a female in the audience, we would love to have you. I'm really, really pushing for more women to get involved in open source. I see so many of them go off to have families, and then when they are hesitant to come back. And one way to do that is through the open source community, because you can learn again. But we need other women to be there to help them. If you want to chat with me, you can catch me at this link, or you can go to the Ortelius website or DeployHub, and you can find my calendar, so you can just reach out. Happy to chat. And one last thing. I've been working with the DevOps Institute, and they have released this availability of this new platform for having discussions. Would love to continue this conversation out there. It's free. It's an actual discussion board, not like Slack where you have a group and then the channel, you look through the channel and you can't really find what you're looking for. It's a discussion group that you can start posting things, and there's moderators out there that are helping, and if they can't find the answer, if they don't have the answer themselves, they'll go look through the community to find the answer for you. So I would encourage you to join the community.devopsinstitute.com. It's not completely full of data yet, but the more we get people interacting, the better. And I thank you so much for your time and your spending the morning with me. Any questions?
Yes.
Please.
So microservices. So one microservice makes a change to its endpoint or interface that some other microservice needs to adapt to. Is that visible or somehow?
The closest we had would be the Swagger information that shows that. We have had people now ask us about how to manage microservices that have close dependencies, and if one gets updated, the other one should. One way to do that is through an application. So you create an application of those microservices that have to get always released as a unit, and that's another way to do it. But we don't have a good way to warn you that this microservice has a dependency on another microservice. I know we're not supposed to do that, but it will happen. Netflix, they call it a application with a little a. And what they do for that is they always release all of those microservices together as an application with a little a, because it doesn't actually provide a customer-facing solution. It's just a collection of services. And that's how what we're seeing is how this is being adopted. So that's a great question. And we're looking at ways to maybe look at the Swagger information and start using the Swagger information to try to predict that. Any other questions? So I told you I was going to tell you about what we're thinking about in terms of making SBOMs a little more secure. What we're doing is we're looking at taking the SBOM information that I just showed you and building it into a blockchain. So you would have a federated blockchain, and what we'd love to be able to do is get the open source communities to start contributing, registering their microservice and of course, their SBOM. And we would then make that SBOM immutable with a blockchain. From there, corporations, enterprises could have side chains that they would show what their application level SBOMs, and that side chain would obviously be a secured side chain for that enterprise. And then you could start bringing that information together in a blockchain that is immutable. So we really want to solve the gap that I talked about earlier. The only way to really do that is to use something like a blockchain to really solidify and make those SBOMs immutable and available to everybody, because one of the complaints that we're hearing is SBOMs are not everywhere. Even though we know that there's a requirement to generate them, they're sitting somewhere underneath in a file system. Nobody's actually consuming them or doing anything with them. The more we make them accessible, the easier it will be for people to make the next step to start consuming them. Any other questions before they chase us out of here? All right, thank you, everybody. I appreciate your time.